So this lesson is on dividing radicals, but really what we're doing is what's called rationalizing the denominator, which means get rid of the radical that's in the denominator of a fraction. For a radical to be simplified, you can't have any perfect square factors, and you can't have any radicals in the denominator. If we look at this one though, some of these you probably could already simplify without even worrying about what that rationalizing things is. Do you know what you do with a? 2 root 8 over root 2? So for 2a, we can just divide coefficient by coefficient. 2 divided by 1, that's 2. And then radicand by radicand, so 8 divided by 2 is 4. And 2 root 4, if we simplify that further, that's equal to 4. 2 times 2, so 4. Can we do the same thing with b? Yeah, it looks like we can. 12 divided by 4? 3. 6 divided by 3? 2. Do I need to do anything else with that?
No.
No, because 2 doesn't have a perfect square factor. If we do c, we'll do 4 divided by 2 is 2. 3 divided by 6 is a half. Yeah, but so we'll put it as a root 2 on the bottom because it's a square root of 1/2. That one is not fully simplified. So that's the one where we have to do what we're going to call rationalizing the denominator. So this is what you need to remember. For a radical to be fully simplified, the radicand must contain no perfect square factors. You guys already knew that. So if it has like a root 8, you need to take out that perfect square factor of 4. We've done that. The radicand must have no fractions. So we couldn't have changed that one into 2 root 1/2 because you can't have a fraction. And the denominator no denominator can contain a radical. So this one, which we did already, we get 2 root 2. We can't simplify it any further just by dividing, but it still needs to be simplified further because that square root 2 in the denominator is not allowed if it's going to be fully simplified. Okay, so let's look at what we do have to do when we come up with something like 2 divided by root 2. The thing is, we don't want the radical in the denominator, so we need to get rid of that root 2. Well, we need to change it into something else. And basically, we need to change it into something that's not a radical, so an integer. What do we have to multiply root 2 by to change it into an integer? It needs to be multiplied by root 2. So I'm going to go multiply by root 2. But I can't just randomly multiply something by root 2, right? Because it changes the value of that expression. But what can I multiply by without changing the value?
-3.
What number could you multiply anything by and it wouldn't change? 1, right. So that's what I'm going to do. Multiply it by 1, but it's going to be a different 1. It's going to be this one, root 2 over root 2. Root 2 over root 2 is equal to? 1. So that's what I'm going to multiply by. When I do that, in the numerator, I'm going to do 2 times root 2, so that's just 2 root 2. And on the bottom, root 2 times root 2, which is equal to 2. And then simplify. Coefficient divided by coefficient. 2 divided by 2 is 1, so it's 1 root 2. How about the second one? 2 root 3 over root 5. What do you think we should multiply that by? Root 5 over root 5. Because that's going to change the denominator into 5, which is an integer, which is fine to have in the denominator. So the numerator will go 2 root 3 times root 5. That's 2 root 15. And then root 5 times root 5 is 5. Can we simplify that further? I don't think so. There's no common factor. Like the other one had a 2 as a common factor, but 2 and 5 can't be simplified, and 15 doesn't have a perfect square factor, so that one's done. When you have a binomial in the denominator like that, to change it to an integer, you need to multiply by the conjugate binomial. conjugate binomials are two binomials that have the first term the same and the second term opposites. So it's a plus b, a minus b. So for this one, this example that we have, it's going to be root 2 minus 7. So here we'll put root 2 plus 7. And what do I need to put on the top? Also root 2 plus 7. So that we're just multiplying by 1. We're not changing the value, we're just changing the way that it looks. So then you need to multiply it out. And it's a little bit more work to multiply this, right? Because we're going to take that 4 and multiply by root 2 and by 7. So we get 4 root 2 plus 28. And then in the denominator, how many multiplications are we doing? 1, 2, 3, 4. 4 things. Root 2 times root 2 is 2. And then plus 7 root 2, minus 7 root 2, minus 49. This should always happen. These two are opposites and they cancel each other out. Those two middle terms. Still good to write them down to show what's actually happening. But they'll always cancel each other out. So we actually have 4 root 2 plus 28 over negative 47. Sometimes you'll see it written where the negative is taken out of the denominator. It just looks a little weird to have a negative number in the denominator of a fraction. So you might see this answer written as negative 4 root 2 minus 28 over 47. And that's not really necessary. It's just kind of convention that we don't generally leave a negative in the denominator of a fraction. So I'm not going to take points off if you don't do that, but just recognize that those two things are the same thing. So if you change all the signs in the whole expression, then it's still equivalent. We changed all the positives to negative, all the negatives to positive. Okay, here's another one. Why don't you guys take 2 minutes and try this one? Okay, so you should have multiplied by root 6 minus root 4 over root 6 minus, did I say root 4? Root 6 minus 4 over root 6 minus 4, which is the conjugate of the denominator. This is what I get when I multiplied it out. Is that what you got? What can I do with the numerator? Anything? No, we'll just leave it like that. And the denominator becomes negative 10. So you could change that to a positive 10 on the bottom, and we'll change this to negative 3 root 30 plus 12 root 5, then over 10. All three terms switch signs if you want to do that. That's what I would do. Sometimes you'll have a binomial over a binomial. But the process is still the same. What are we going to multiply this one by? 4 plus 5 root 5. This one's going to be a lot of work. We'll get, let's see, 4 root 5 plus 5 root 25. I'll write it out like that. And then we're going to do 2 root 2 by both of those, so that becomes 8 root 2 plus 10 root 10. That's a lot of terms in the numerator. And then in the denominator, 4 times 4, that's 16 plus 20 root 5 minus 20 root 5 minus 25 root 25. And then look for things you can simplify in the numerator. 4 root 5 can't be simplified, but that 5 root 25 can be simplified. What's that equal to? just 25, right? The root 25 is equal to 5, so 5 times 5, that's 25. 8 root 2 can't be simplified. 10 root 10 can't be simplified. 16, those two middle terms are gone, right? Cancel each other out. And then 25 times root 25, negative 125. So the numerator is going to stay as it is. And the denominator becomes 16 minus 25, which is negative 109. We could switch all of those in the numerator to negatives and make the 109 positive, but I'm not going to bother in this one. So here's the last one, multiplied by 4 plus root x over 4 plus root x. Root x times root x is just x, or you could have had root x squared, but that simplifies just to x, so that gets rid of the radical in the denominator, and there's nothing further you could do with that one, so that's fully simplified.